All right. So, this is me. So, I'm Amine Benammar, OT, Operational Technology Manager for Air Liquide, North America. Background in automation and over 20 years of automation and controls. I manage operational technology for Air Liquide. I define cybersecurity guidelines for the group. I consult on OT initiatives, OT projects, validate the risks for the OT projects. I am also the Air Liquide international expert for the group. So the agenda today, so we'll go over Air Liquide for those who don't know what's Air Liquide doing. Evolution of communication protocols within Air Liquide, why we are using OPC, for what, and the vision that we would like to have for OPC for the future. So what is Air Liquide? So very often I'm getting asked, what is Air Liquide? And I think the best example is we provide oxygen for the hospitals, medical oxygen, but we are not doing only that. So we have over 60,000 employees. We are around 60 countries. We have 2 million industrial customers. We have 2 million patients support at home. We have to support these customers over 300 ASUs. We have cogeneration plants, hydrogen plants, and almost 10,000 kilometers of pipeline. So this means a lot of industrial IT, OT stuff that we need to manage. I'm a big fan of dystopian movies, so I don't know if you are. And this is a tribute to almost a 100-year movie. It's called Metropolis, 1927. It's one of the first dystopian movies. I think this triggers our imagination for the best or the worst. But in my case here, I wanted to show up what could be the worst. The worst if we don't have OPC, actually. And I think we've been there somehow one day. So I think it could be very chaotic. Inefficiencies, a lot of interfaces that we need to custom for the different devices that we have. But we don't want to go there. And we want to have security embedded. We want to have no industrial failures. So I think this is the first robot, I think, in the dystopian movies. Don't use it, Mike, because it was not doing great things. This is a quick overview of the evolution of Air Liquide usage of OPC. So at the beginning, I think like all of you guys were the control system world. Before we had DCSs, 1995, 2008, we tried to implement MVPC. We were trying to implement advanced control. And we had a plethora of different SCADA systems, different DCSs. It was very resource consuming. And also the deployments were not that easy. Today, I'll go very quickly to this present. Today, we are asked to deploy very quickly new technologies, new applications, and we have less resources, of course. And OPC actually helped us a lot to deploy quickly new applications at the corporate level and also at the lower levels of our industrial systems. So background, when I joined Air Liquide 12 years ago, it was a very special landscape of control systems. We developed our own clients, our own interfaces. Most of our control systems, we were using Bailey. I don't know how much you know about Bailey, but Bailey was not very friendly in terms of communication. And it was very costly. The CIU interface, the homemade interface and communication wasn't very easy. So it was very obvious for me that we needed to move to a standard. I'm not saying OPC, but it was very obvious for me that interoperability and efficiency and also reliability was very, very important. And one of the very good examples of this is our enterprise historian. So enterprise historian, we are collecting process data for all our sites and, and actually standardizing as much as we can with OPC, deploying OPC servers for our control systems really helped. And I had a very good comparison between Canada and the US, where we invested a little bit more money in Canada for our OPC servers, and we reduced our critical path by not only 6 months, but almost a year. So it took for the US much more longer to deploy because we are still using proprietary interfaces with our control systems. Our control systems were still legacy old control systems. But in Canada, we had the idea that we don't have a lot of resources to maintain our OPC interfaces, our communication, and to maintain our SCADA system. So the transition for us was much smoother for Canada than comparing to the US. And then we said, okay, we're gonna apply the same strategy for Canada and for the US. We will upgrade our OPC service. And until now, we are still doing that. We are upgrading our OPC service and trying to move as much as we can to OPC UA. So this is the evolution within Air Liquide. For what we are using OPC, I think we are using it everywhere for all our industrial systems. And we try to push as much as we can for OPC. And of course, we try to push for OPC UA. So we are using it for enterprise historian, and we do a lot of things with our enterprise historian. We do predictive analytics, we do performance, we supply chain management, almost all the processes within our company, custody transfer, we do it with our OPC servers. With enterprise historian, and we collect all the information and we bring that up to the corporate level. We developed our own OPC as well. We had our own homemade SCADA system. And with the help of the OPC Foundation, actually in the documentation, we developed our own OPC clients, which is very strange because some of these clients, they worked a little bit better than some vendors, gateways. It was more reliable even. I don't know how much familiar you are with multi-links, but we have a lot of electrical relays. And most of them, at the beginning, we were using Modbus communication. And at the end, we realized, no, it's not going to work. We need to go faster. We need to collect the information with the OPC servers, collecting all the information for us, mapping the data to our OPC servers. So for some sites, we had 5, 6 multi-links. For others, we had 20, 25. And we had to deploy that for all our sites. So the choice for us was very easy. Get an OPC server, get all the information mapped, and forward this information to enterprise historian and to our main control systems. Advanced control. I don't know how much familiar you are with advanced control, but that's something very important if you want to increase the performance of your processes. But if you want to do advanced control outside of your main control system, you need a very reliable communication. And OPC is the way to go. I don't know how much you want to do advanced control, but believe me, you need a good, reliable OPC communication. You can try to do it with Modbus or other proprietary protocols, but at the end, you're going to find out that you have different control systems and you need to standardize to something. We also implemented sequencers. So the beauty of when you have a reliable communication is that you can have different approaches with process control. So the modular approach. You don't want to have an overcomplicated logic within your control system. You want to have different teams working on different packages and not going through a very, very complex main control system. So having our sequencers outside the main control system helped us not only develop faster and reliable sequencers, because we had to make so many changes to the logic, and also helped us quickly resolve some operational issues and find out that, hey, we had these failures and we have been doing the same thing for so many years. Having the sequencers and the ability to communicate between the control system, to load configuration changes to the sequencer very quickly without impacting our main control system really helped. And we did it also through OPC communication. So, and we pushed a lot for OPC, UA actually, Unified Architecture. So when we choose the applications that we use for the sequencers, of course we evaluated the interfaces that these applications were using. So for me, it was very important to choose an application where I can come back to the vendor and say, hey, I need a reliable communication. Can you fix these bugs? What's going on? And we needed to be agnostic to the control system. So to communicate with different control systems reliably. We do also integrate with different third-party systems, and we do a lot of web developments for very specific business applications. So as you can see, I think we are using it in all the different process functions. That's control systems. Aspiration, vision, upgrades. So going back to my dystopian movie, or my dystopian dream or nightmare, I don't want to go back to the past. I don't think that having proprietary protocols, custom protocols is the way to go. Today, there is certified OPC UI interface, and I think we need to push for that to ensure robust and stress test and functions under various conditions. So there is this process, and I think we need to push for that. On our side, we really think that's the way to go. And that will enable us to do more cutting-edge technologies using AI. If I have reliable communication, I don't have to worry about the quality of my data. I will spend less time validating this data. I'll go straight, implement new technologies, machine learning, and edge computing. Try to implement AI on bad quality data. Don't think that's gonna really help you, even if you have a very, very good model. Standardization across the industries. Also that is very important, I think. The reason why, we have different customers. We have customers in oil and gas, we have customers, NASA is one of our customers. We need to send data, we have custody transfers that we need to forward to our customers. If we can standardize between our suppliers and our customers, it's gonna make our life easier. So pushing for standardization, I think will really enable us to be more efficient in the future. I like the concept also of digital twins. Very often you work with process control people, they say, you know, how we can test this. Chemical engineers say, oh, it's very complex, we need a lot of time to test this. It's hard to build also simulators for our processes. But if we enable real-time interfaces that are very reliable, it's gonna help us also build very good digital twins for our plants and for our, maybe even our corporation. What we are looking for also is redundancy, reliability, and autonomous plants. So as I said, we are trying to minimize the risks, increase reliability, and that's the vision, I think, for our future. Enabling better interfaces will enable us to do more autonomous plants. And as I said, more important for us, certification and getting that we have a standard. Let's follow the standard for OPC. So that's my last word.